Good morning, students. So today we are here to discuss the chapter 4 of chemistry of class 7th, and the topic is atoms, molecules and radicals. So student, this chapter is divided into two parts. So today we are going to discuss first of all the part 1 of this chapter. Now, so the topics which we will discuss in this part 1 of this chapter are about atoms and molecules, radicals, periodic table and valency. So first of all, the things which we are going to study is about the atom. So atom form molecules and often another kind of entity, we call it as radical. So in this chapter, we will study that is about first thing that is about atom. So first thing is the definition of an atom. So an atom is the smallest part of an element that take part in a chemical reaction. If we keep dividing a given mass of an element, we will finally get an individual part that has all the properties of the element. Such an individual part is called an atom. It is the atom that take part in a chemical reaction. Thus, the property of an element depend upon the atom constituting the element. Now the next topic is valency. So it is the combining capacity of an element. So first is the definition of valency. The combining capacity of an element with other elements is known as its valency. The valency of hydrogen is considered to be 1. Therefore, the valency of an element is expressed by the number of hydrogen atoms that combine with one atom of the element. It is also given by the number of hydrogen atoms that an atom of an element replaces in a compound. Element with valency like 1, 2, 3 are said to be monovalent, divalent, trivalent, and so on. So here you can see one table also. So monovalents are like hydrogen, fluorine, chlorine, bromine, iodine, while divalents are oxygen, sulfur, magnesium, calcium, zinc, and trivalents are nitrogen, aluminum. Tetravalents are carbon, silicon. Now next is about molecules. So first we will discuss the definition of molecules. A molecule is the smallest part of an element or a compound that can exist independently. Atoms usually do not exist independently and tend to combine among themselves to form molecules. When an atom of an element combine with another atom of the same element, a molecule of the element is found. When atom of two or more elements combine among themselves, a molecule of a compound is found. Like for example, two atoms of hydrogen combine with one atom of oxygen to form a molecule of water. So as you may be knowing, the formula of water is H2O. So as two atom of H2 and one will be present of oxygen. So if we do the chemical reaction, so it will form H2O. So now next is molecules are represented by formulae. Okay, so as to represent the molecules, we use the formulae like water formula, as we have previously discussed, that is H2O. So number of atom contained in a molecule or a compound is called its atomicity. So here are the some formulae of element like a molecule of noble gases. Example is helium, neon, argon, contain only one atom of the element. Hence, the molecule of these elements are represented as He, Ne, and Ar. These gases are said to be monoatomic. However, a molecule of hydrogen, nitrogen, oxygen, fluorine, bromine, iodine contain two atoms of element and they are called as diatomic and are represented by H2, N2, O2, F2, Br2, I2. So now next is, so in trivalent, it is a common example, that is ozone, and it is represented as O3. Then the atomicity of, we talk about phosphorus, so it is tetravalent and it is represented by P4. And next is octaatomic, so that is sulfur and it is represented by S8. Now next one is formulae of compound. The formula of a compound found by two elements called a binary compound is obtained by transposing their valencies. Suppose you can see here one diagram. An element A has a valency Y and an element B has a valency X. Then the compound found between A and B will have the formula AXBY. There are some exceptions like S2O2, we call it hydrogen peroxide, in which the numeral subscripts are not divided by the common factor. So this is now formulae of some common binary compounds. So elements with valency they have given, then their formula, and then name of the compound. So first one, that is element with valency Na1 Cl1. So formula will be NaCl, and the name of the compound sodium chloride. Then next is Mg2Cl1. So the formula will be made MgCl2, and the name of the compound magnesium chloride. So the number which is written on Mg2, it got changed in intersection, like it goes to the Cl side and the Cl1 will come to the Mg. That's why the formula is MgCl2. The next is Al3Cl1. So formula will be AlCl3, and the compound name is aluminum chloride. Then next is Na1O2. Formula is Na2O, and the name of compound sodium oxide. Then next Mg2O2. Formula is MgO, and name of compound magnesium oxide. Then next is Ca2O2. So both that, as they have the two valencies, so both will cut. That's why the formula is CaO, and the compound name is calcium oxide. Next is Zn2O2. Formula is ZNO. So as their both valencies will cut by each other, that's why the formula came ZNO, and the compound is zinc oxide. Next now Zn2S2. So the formula is ZNS, and the name of compound zinc sulfate. Then Mg2N3. Formula is Mg3N2, and the name of the compound magnesium nitrate. Then last one, Al3N3. So as both have the valency same 3, so that's why they will cut each other, and the valency will come Aln. So the formula is Aln, and the name of the compound aluminum nitrides. Now the next is variable valency. Some element have variable valencies. For example, they have shown iron has a valency of 2, as in you can see in one formula FeCl2, and in 3 valency FeCl3. To distinguish between them, FeCl2 is named iron second chloride, and FeCl3 is named iron third chloride. This method of naming a compound is adopted if it contains an element with variable valency. So some elements they have shown with variable valency, like copper valency is 1 or 2, iron valency 2 and 3, tin valency 2 and 4, lead valency 2 and 4. Now formulae of the molecule of element. The valency of an atom can be satisfied by an atom of the same element. For example, the valency of one hydrogen atom can be satisfied by the another hydrogen atom to form the molecule H2. Molecules like Cl2, O2, and N2 are formed in a similar manner. So here you can see these are some diatomic molecules like hydrogen, as they have represented by the same color than nitrogen and oxygen. So student, up to formulae of molecule of elements we have discussed in the part 1. So remaining topics which are left, that will be discussed in the part 2 of this chapter. Thank you, student.